live.
Thank you. Hello, this is our forum. We have an opportunity to have a group discussion with Marianne, Michael, Kurt, and Prasad, specifically around information architecture for artificial intelligence. So we're going to start with brief introductions in case you haven't had a chance to meet some of our panelists. We'll start alphabetically with Marianne.
Hello, Marianne Sweeney. I'm an information architect. I have my own company, Dataless Information Systems. I'm also working full-time embedded on a digital marketing team for a SaaS company where I cover information architecture, user experience, and content strategy because, as we all know, they're very much the same. I'm delighted to be here and look forward to discussing how we can get information architects earlier into the system, whereas said in Hamilton, in the room where it happens.
Let's go over to Kurt. We'll just go sequentially.
Okay. My name is Kurt Cagle. I'm the editor of the Cagle Report. I am an ontologist. I'm an author of 25 books at this point, and working on my 26th right now, which is called Ontology, a Layman's Guide to Language, which I should have thought of the last time around. I, too, have been working in the information architecture space for probably about the last 30 years now, and have been very fascinated by language, very fascinated by how we use it as a means for corporate communications. And when AI came along, I thought, oh, wow, this is really kind of cool. We are now dealing with yet another form of corporate intelligence, and we're beginning to kind of come to the realization that it's kind of changing the way that we think about information overall. So it's an exciting time to be working there.
Michael.
Hi, thank you for having us today. It's exciting discussions all day. My name is Michael Iantosca. I am the Senior Director of Knowledge Platforms and Engineering at a company called Avalera. We do sales tax services for backends of thousands of sites around the world for automated computations. I spent 44 years as a content professional, 38 of them at IBM. I spent quite a bit of time developing DITA as a standard that emerged from a work group that I formed at IBM, and very deep into structured content. And I've been involved with artificial intelligence since around 1990, when I began with expert systems, Smalltalk and such, and then IBM Watson and computational linguistics. So that was a hobby for me, and the hobby became a profession, I think, when generative AI came of age, and I realized this is far more than I ever expected it to become.
And Prasad.
Thank you so much. I'm delighted to be part of this panel. I have had a session early on today in the morning with Marianne. I thoroughly enjoyed that discussion. For my background, I am the founder CEO of a company, Lead Semantics. We have developed and we market a tool called Text Distill. The mission for this tool is to take in unstructured data, language being, the main data that gets pumped in, but all media is just fine. Any unstructured data, video, audio, and image. And then we apply an ontology, and then produces the output is a structured knowledge graph in RDF that is readily available for querying in Sparkle, and then it has an API and so on. And so this is in its production, it's the second year in production. And so we have been at it for some time. So we thought we were like early groups working with ontologies applied against generative AI. But I'm so pleased to hear many folks, and it's very pleasing to learn about other teams, other groups that are coming up with the similar ideas, and have seen the value of having ontology and knowledge graphs together with generative AI. It's not just a buzzword. It is a true gap that could be filled, and the only way to fill the gaps left by generative AI is with a knowledge layer of sorts. And so I think it's the best time to be working in this place, today. That's what we think.
It is very exciting time to be working in this space. And I think what's so interesting is that we all may have different definitions of what information architecture is. So if we can go around and just quickly define what information architecture is from our own lenses. And so we'll start with you, Kurt.
Okay, so when I hear information architecture, it's a little bit different than what we think of when we talk about data architecture, but not by much. I think it's actually kind of the supergroup that data architecture is part of, and that is, as I discussed earlier today, it's basically the way of making the good relevant data or information that you have within your organization accessible, accurate, timely, and meaningful, while at the same time working to ensure that the bad data, information, misinformation, disinformation, dirty data, essentially doesn't enter into the system, or when it does enter, is something that can be readily filtered out and quarantined. With that in mind, that's a very complex area. We talk about structured data and unstructured data. In my way of thinking, all data is basically structured in some ways and unstructured in others. It is simply a way of thinking about how that data is organized. When you talk about a book, for instance, you have, the structure that we think of for a book, chapters, subsections, and so forth, but those don't necessarily correspond to the actual information of the book itself. So there are structures that you have and structures within structures, different ways of interpreting the way that we store and work with that data. And it's that process of trying to ensure that we can communicate those structures as well as the data itself between participants so that everyone understands essentially what's going on with the content itself. So that's where I see the role of AI, or excuse me, of IA.
Your mic is muted, Jessica.
Marianne.
Wow. Well, as we've mentioned, for me, information architecture has changed dramatically over the last many years. Now, information architecture is about organizing and labeling information so that it can be consumed in a meaningful way by individuals and machines to find what people are looking for.
Beautiful. Michael.
Yeah, it hasn't changed in a long time, actually, but it's expanding is what's happening. It's the way information is organized and structured and presented to users to maximize and help them efficiently consume and accomplish the goals that they're trying to do it. And that involves creating the logical structures, making the content easy to find, easy to understand and consume. It involves the traditional areas of organization, navigation, consistency, accessibility, flow, all of the things that that are foundational to information architecture that we've learned over the many years. But it's expanding. I think I agree with what Marianne said, that it's getting, the field is getting bigger, right? We introduced the notion of intelligent content that is dually useful for both humans and machines, where we can automate and support things like omni-source and omni-channel delivery and architect our content in a device and channel independent way, for example, and then enhance the content with additional intelligence in the form of taxonomies and ontologies, and now graphs coming along. And the more interesting area for information architects is there's been a parallel world going on. And that parallel world has been information architects, especially in the tech doc area, have not necessarily been in the information architecture world of knowledge management professionals, people that delve into those weird areas of ontologies and Sparkle and RDF and property graphs. And these two worlds are fast merging. And I think the exciting thing there is when these two fields merge, they're not going to be just information architects anymore, right? They're going to be knowledge architects that comprise both of those areas and more.
Prasad.
Yeah, my take, pretty much, I mean, what I hear all around is exactly what I would like to say, but in probably in different words, I guess. Like general architecture that we are all familiar with, like when it comes to buildings and things like that, the goals of an architecture are, like functional goals, maybe resource usage goals, like user experience goals. To meet those goals is how you plan your architecture. It's like organize your resources and your planning such that these goals are met most efficiently. It's the same thing with information as well. uh, and in order to facilitate these goals, I mean, you would have to organize the information. And in order to organize the information, there are definitely a number of techniques, ontology being one of them. And ontology is a wonderful tool when you look at it as the knowledge that is the content of the information that is being disseminated. And so knowledge is this abstract intermediate construct that needs to be shed light on. And as soon as we get a chance to focus on that, then there are fantastic tooling and all the standards of several years that come into play, and all of those things can come in and really enhance the overall architecture that we are talking about. That's how I
Perfect.
view it, being that we sell a tool in that space. I kind of skew it all around to that, which happens to be, I think, probably where the new AI is going.
Yeah, and I think it's a very interesting point, the idea of the knowledge management space and the information architecture space also converging around some of these topics. So I want to open it up for discussion on how can IA or information architecture influence AI?
If I may go,
Yes.
so for AI, the case in point today, at least that everyone is aware of, generally, like generative AI, large language models, one of the shortfalls or something that we would like to address in an enterprise situation is to be able to address this problem of hallucinations or confabulations or whatever suits the situation. Uh, and the reason is very well known that the architectures of large language models are as a feature would produce these hallucinations, and as such trying to fix that through increased training and things like that probably may not be the best approach. The other way is we have these ontologies which is like managing the knowledge area, and the reason they become an apt tool to overlay on top of these generative AI processes is that something is right or wrong because whatever is produced does not meet our expectation. And our expectation has a structure now called ontology, because that expectation is nicely organized in the form of an ontology. And so when generative AI, produces something, you can measure it against the ontology and then say it is right or wrong, or whatever the difference that we, and then plan to fix the issue right there. And that is how probably workflows can really be automated, because the ontologies are there at a very granular level, again depending on what is whatever is required for your workflow. So automated workflows would necessarily require an ontology, versus if the outputs of generative AI are for human beings, then human beings are making up for the difference. They are making up for what is lacking, and getting excited even if it is like 85% accurate. They're making up for the rest of the 15% that's missing. So a lot of the times, so we are missing the opportunities for honing in and pointing at the alternate tooling that is available readily, that will make up for the difference in an automated fashion.
Yeah, if I can
That's my point
jump
of view.
in.
Yeah.
I think you actually brought up an interesting term, and I've mentioned this before in some of my own writing. I consider an LLM to be one of a class of what I'd call a confabulator. And this is a term that we haven't actually used very much just yet, but I think it's going to become more and more prevalent. An LLM is not a database, and this is something I keep trying to stress to the people that I give presentations to in my classes and so forth. That it is essentially a way of generating or constructing results based upon input that are a transformation of a prompt or something along those lines to then produce output that's meaningful in some way. So it's much more of a transformative case, but it's a generator. And because of that, because we are still trying to deal with the LLMs as databases, and I don't think they are, we tend to make a lot of assumptions about what a good LLM should and should not do. So, when we get back to the issue of a knowledge graph is a database. It has all of the characteristics that you're looking for in a database. It has transactional awareness. It has curatability. It has the ability to manage versioning. It has the key pieces that you would come to expect within any other form of database. It's a way of representing specific facts or assertions that we can then augment with metadata to determine things like when is it appropriate, where is it appropriate, is it true all the time, what its provenance, where does it, what is the reliability, where are the relevant keys that you have within that data set. The distinction between that kind of a database and others is that it's different in that it actually works better for managing connections than your typical relational database. Relational database, adding a table is an expensive operation because you basically get, the more tables you have, the harder it is to basically manage the resources. And once you get up to a certain point, the complexities involved in these become much more difficult because you're lacking the metadata necessary to handle those complexities. A knowledge graph is a graph. It's an abstraction that allows you to provide the metadata necessary to allow you to make those queries, not just at simple levels, but at pretty deep levels. I can basically go in and say, give me a tree or a hierarchy of information and retrieve that and do things with it in ways that would be very difficult to do in a typical relational database.
Oh, wait, I have a question.
Sure.
The difference, though, is that the system, the AI or the LLM, exhibits a certain level of intelligence that allows it to act independently when engaging with the information.
Well,
So, you're right. It's per query or prompt encouraged, but in the end, it's the system that makes the decision on what to present and how to present it. And unlike databases that we create or our storage repositories, we have no insight into how the machine makes that decision.
Absolutely.
That's weird.
And it's actually comes back to the whole question of security.
Right.
I had someone come up to me and say, hey, I want to basically talk an RFP about, creating secure LLMs. And I said, no, don't. It's not possible because you cannot see the processes involved. You
Right.
have to basically look at those LLMs and say, look, the best we can do is make suggestions. That's what a prompt is. It's a suggestion. It says,
Sure.
think of things in terms of you are a blank. And with that, use that to basically determine what kind of responses that you're going to get. But it is something that it's not It's not something where we can directly say, give me specific information about this thing. We can only kind of hope that what we're going to get in this way, we can only hope that it actually gives us something close enough that it resolves a problem. Sometimes it does. Sometimes it gives us great information.
Depending on the individual who
Depending
makes the
upon the
query.
individual. Yeah.
Well,
And depending upon the prompt, depending upon the context.
mhm.
Without, but at the same time, sometimes it will basically provide information that is not only not true, but is also likely to put you into legal liability in ways that databases just don't do.
But
You know,
here's where information architects can make a difference. Because
yes,
if we were included earlier, then we could bring some human factors, tools, and understanding so that the rules and regulations that the system is operating under are more robust to handle those types of situations.
Well, the old adage applies here: garbage in, garbage out. Okay, it's very, very, very basic. And so, I don't know many shops that are just using the large language model. I mean, we can just use them as a confabulator, Kurt, as you say. It's how, what kind of information do we retrieve, and do we fact check that information? These are probabilistic models, right? The words it chooses are the most likely closest used words over billions of instances. And so it puts them together through those layers. I don't care. I don't want to use that. I don't want to use another probabilistic database to go retrieve content. I want deterministic, fact-based decision making as to what I'm retrieving, and the very limited amount of information I'm retrieving to give to it for an answer has to be precise. And that means I need reasoning and inferencing, a real reasoning, not the kind of thing you see from GPT 10, whatever they're putting out there, and the games they're playing there. And that has to be based on factual data. A couple of years ago, 2 years ago, I put out a model. It was called the Semantic Content Maturity Model. And Jessica, you can post that link out there. And it sort of went viral because it basically provided a path by which we can build these fact-based deterministic models that do reasoning and inferencing that the base LLM and the vector-based RAG models don't do. In our models that we've actually put out there for open use and open extension, we're not even depending on a vector database for the retrieval at all. We're using the graph entirely. Do we use a vector? Only to analyze the graph, but not to do any content retrieval. And when you read that, you'll understand that we reduced the probability factor to only the LLM and removed the probability of the vector database, where they chunked and ripped up our content and lost all context and links and everything else. So, if we follow the idea that we can create, and we found ways to automatically create reliable knowledge graphs out of our content, that if we create the knowledge assets, and that becomes our intellectual property, that becomes our competitive weapon, by the way, against your competitors. You don't want some generated, thing that you can't tailor and control yourself. You need to own those ontologies. You need to own the content. You need to own the taxonomies and the labeling of the content. And that has to be completely under your control for the kind of content most of the people on this call create, which is topic componentized, architected content. And then we can use those other models for the unstructured blobs out there that most of us don't deal with, okay? And the two can be combined into a common model where you can use the right technology. You can use, an RDF graph. You can use a property graph. You can combine them together. We've worked across all these areas, and it's not a one-size solution. There's not a silver bullet here. You need to look at the data sources that you have to pull from. I mean, people aren't even talking about the fact that we have to pull data from data sources to work with the content. In my support bot system, half the questions people are asking is not about the product, it's about their accounts,
But
which is in our CRM database. And all that data needs to also come into the question and answering. So otherwise, 50% of the questions that come into our support portal don't get answered. And so you got to say, which model do I use? Which pieces can I combine? And then keep doing what we're doing with content, which is make our engineers who are building these models use our intelligent content and as the source of truth to drive those models.
herein lies another problem, though, and that is one, we have no insight mostly into the training data that is used for the model. In addition to which, the models, if I'm not mistaken, are developed to continue learning, to continue crawling and associating, not just on their training data, but on new data that they encounter, especially with the web-related ones. And now what you're finding is, at least outside of the enterprise, a lot of individuals are sort of not happy that ChatGPT is using their website as additional training for their models, or any and all websites. So they're closing off the access to new or novel data that will make the models better.
Yeah,
Well, and
oh,
I was going to say, just when we built our model, right, and we're using, a large language model underneath, we're not using any of the content that model has generated an answer from. It's only being used to actually do the semantic regurgitation, if you will, of the content we're giving it. We're not training the public model. It's all private because we use the APIs that don't allow it to be training a model. And we're not using any of the information or that's been fed into the large language model to generate an answer. We're using only the content that we're giving it that's our private content. So, it depends how you implement the model. If you could use the large language model's knowledge, or say, I hate to use the word knowledge, but information that it has stored, but that would be kind of silly because you can't trust it, right, at all.
Yeah.
Yeah,
And Kurt, yeah.
Several things. Absolutely, I think the issue of that data reliability is a big key, but as well, there was a mention of training, and when you think about it, actually, even before that, there was a mention about labeling, which is actually, I think, key. Now, I know that when I was originally exposed to LLMs, and this was back around 2018, 2019, just about the time that Google, published their paper. The problem that I saw with that was that what a lot of organizations, or a lot of these initial data scientists were working with and saying, well, okay, we're dealing with training, was to basically take models that had already existed and essentially flattening out a lot of the really interesting informational relationships that exist there in order to be able to get to the point where you have something that could create these large latent spaces. And that information, that flattening that was so critical for labeling, gets lost in that training. You don't have people that are trained to think about content actually doing, the question of talking about semantics and talking about structure and talking about the fact that most of the information that you're dealing with is not information that can be directly gleaned from, here's a lot of information coming from a data system. That means, among other things, that when you start talking now about systems that are doing things like code generation, they're not actually all that terribly effective. They'll go from, in some cases, yeah, you can get accuracy or get reasonable content coming out of 80 to 90%, but you can also get content coming out at less than 1% of utility. That basically comes out because we are dependent largely upon this aggregation of throwing, literally the kitchen sink into the training without actually talking about structure, because we haven't thought about what that structure means. There are ways of encoding graphs, but we haven't really got to the point where most of the people that are building these models are actually talking to graphs. And it's only now that we've started looking back at it and saying, look, we have RAG as a vehicle. A lot of people in the data science space really did not like RAG because it was not neural networks. It was not something that you could say, hey, look, my neural networks can do this. No, most of the information you have is basically coming through a back channel. And it's coming through a back channel because we don't trust what you're putting into that system. And, until that gets fixed, until you have a way of being able to say, look, I need to be able to talk about something where my hallucinations, my inaccuracy with regard to how the latent space translates into a semantic space is sufficiently fine-grained. No, they're not going to take off. You're going to see more and more organizations say, look, we're kind of backdooring our way into semantic systems because we all got really excited about LLMs. They were great genies. And then we discovered that, like most genies, they actually have, their wishes come with conditions.
That's a great way to put it. Yeah, exactly. And touching on semantic systems, I just want to transition for a second about where does semantics fit in to this architecture? If we look at RAGs and knowledge graphs, like what are semantics in the context of this information architecture? Prasad.
Yeah,
Yeah.
just to continue on what Kurt was saying and what Michael said early on, the generative AI architecture is doing what it is meant to do. I think we are probably expecting to latch on this the tremendous responsibility of the knowledge database to be also part of the generative AI models, which it is not meant to be. It is only meant to do pattern recognition and whatever regurgitation, whichever. And that is great. That is what intelligence is meant to do, detecting patterns, which is like the cornerstone of intelligence. Knowledge is a different artifact altogether. Historically, that's been the case. Knowledge and language are two different sides of the same coin. I mean, I kind of mention it any place I go. These two are not the same. Language is meant to communicate the knowledge, but you need language is not knowledge. Rather, knowledge is not language. And so trying to latch these two and clasp into each other is probably a little bit of a misnomer. Probably may not be the most efficient way to attempt spending all the money in training and retraining with all this big, huge mass of money going into it. Instead, we have wonderful technologies to encode and organize knowledge, which is these ontologies, and we have standardized standards for over multiple decades now. And now generative AIs have come, and so the intelligence side of it, which is like the language side of it, is kind of addressed there. So if you see it that way and organize a way to have an artifact that handles both of them together there may be a lot of creativity that probably has room to play out in terms of maybe you would introduce an ontology as part of a system prompt and and feed in all the data and let the prompt take the ontology be the guide to how it interprets the data that it's looking at. That's one way, and maybe there are other ways, and RAG is certainly one of those architectures for that. But I think that is the right approach instead of expecting the generative AI to kind of increase, even if it reaches 100%, which it'll never be. I don't know what that 100% would ever mean in terms of performance or accuracy. And even at 85%, together with a wonderful ontology for a specific purpose, you can get your 100% in an automated fashion to run your agents, for example. And that is today available, that approach. I think the world ought to take a little bit of a twist there, and I think the wise minds here probably see it. But there are many other forums that totally generative AI focus still need a little more of a pep. to see it this way, I think.
Now, I will kind of issue a counter to that. Although I agree with you, I agree with you pretty much on everything you said. The problem that you run into with an ontology is an ontology is still a model. It is still a way of basically saying, I have information that I want to be able to capture, and that even though we've had ontologies now, if you look at RDF, 30, 40 years, you can go back to be able to say it. I still struggle to be able to define what exactly an ontology is. I still struggle about what is the best way, I'm writing a book about it, but what is the best way of building an ontology? And that in turn means that, we are still dealing with essentially ways of organization and means of organization. And that process, the process of organization is something that, yes, when you can actually use an LLM as a pretty decent organizer. It does, in fact, do. If you talk to an LLM and say, look, here are the constraints that you are currently working with. Now build an ontology. It'll do a pretty damn good job. It's not perfect, but it's surprisingly good. And I think that when you get into, what your organization is doing, Prasad, and elsewhere, we have that capability of being able to say, okay, what are the constraints that we are looking for in order to be able to describe this information in a meaningful fashion? And so when we talk about these knowledge graphs, we have to understand that there are problems in that space as well. It is very difficult to be able to come up with a decent ontology. Several very brilliant people have tried. And, the landscape is littered with ontologies that never succeeded because they were too complex, because they didn't fit the problem domain in question, because they required a level of expertise that simply wasn't available, because there were expectations about how to be able to query it. All of these things are factors that, while ontologies are good, and I think they're essential, they're also not magic bullets.
Does that presume that there is a silver bullet ontology, one ring to rule them all?
I don't think so. I've been doing this for 40 years, and I have never found. Yeah.
It would be great then to be liberated from that expectation and just say, the utility is unique. Sorry, Michael.
No, it's okay.
Just add just one point to sorry, Michael. Just one point. Clearly, the challenge with ontologies, I agree with Kurt what he had mentioned. It is not an easy thing. The ontology, the engineering side of it is not easy, and there is not enough expertise around, and things like that. But one of the biggest learnings that we have had in our practice is that to putting a properly delineated goal is the first most important thing in developing an ontology. Your competency tests are the guideposts for every decision that you make, because ontology development is a highly iterative process, and definitely because one of the cornerstones of ontology is that you are modeling based on the real world, and so your epistemic reference point is the real world. And so you tend to kind of get really broaden out because everything tends to be creeping in. It's all appears to be legal and things like that. So unless you have a very rigid, rigorous mind to kind of adhere to your guideposts, you are bound to kind of extend yourself, and that's where one of the biggest challenges that we had seen causes the failures in ontology development. But if you stick to the specific goals, they tend to be pretty effective. I'll stop here.
We have to, like anything, there's there's truth on both sides and in the middle. Okay, when we set out to build a knowledge graph of large scale of our content, there wasn't one kind of ontology involved. Okay, we realized that most of us had structured content already. And Jessica, you asked the question about semantics and how that fits in. Our content already is rich with semantics in many cases. Okay, it already has structure. It has schema that governs it. And when you have a schema, and this is a basic 101 knowledge graph thing, when you have a schema maps to a structural ontology automatically. I mean, it almost doesn't require a whole lot of work at all. In a day, you can have a standard ontology. So what we did was we took a standard, which provides a schema for a collector map, and we turned it into a OWL ontology. And we put that in a graph database. And then we threw thousands and thousands and thousands of topics at the graph database. We just converted the stuff into an RDF stream with a simple transform from data to RDF. And whoosh, magically, we had, in less than a week, we had a massive knowledge graph that was accurate of all the relationships and linkages of all of the content. Now, that's the structural ontology, and we're giving that to the world for free now, right? We're giving that to you. Read the paper, please, because we just spent 3 years to actually get to this point, to give people a way to do this. That doesn't have in it, though, the domain conceptual ontology. That's what you have to spend time developing to overlay or combine with that structural ontology. That's where your particular domain, whether you're in medical or you're in legal or you're in taxation like me, makes those connections in addition to the linked data, which is what we already own and have. And so with the semantics that we have in our current information, if you're structured, you have it better because XML and SGML and JSON can hold a lot of metadata, and you can even add metadata to Markdown, right? We not only have developed our content and domain ontologies and taxonomies, our writers, we're giving them tools to assist them, recommenders, to apply more taxonomy and ontology to the topics themselves, to make the topics themselves even more intelligent than the structural that we've been building in for years and years and years. So now we're augmenting our semantic structure in the source, and we're using the source. We're not pulling web data. We're not pulling PDFs. We're going right and pulling your Markdown or your DITA or your XML or your SGML or whatever it is, and we're putting all of those topics in the graph database. And like I said, we've automated the process. Now, does that work for big unstructured blobs of content? No. We'll have to punt and combine a vector retrieval model, for that one. But most of the people on this call, I'll bet dollars to donuts, have already topicized and modularized their content and have labeled it pretty darn well. And it would be a sin not to leverage that out of the gate and jump into the first place because you've been building it for years and years and years.
Yeah, this is part of the reason that when I talk about what an ontology is, I basically break it up as an ontology usually consists of 3 parts. One part is structural. It's basically the relations that exist that allow you to be able to create data structures. The second is taxonomic, talking about topics. And that's basically domain knowledge. That's essentially how do I effectively identify a potentially continuous information so that I can basically break it down into labels of some form or another. The third part is usually operational. It's something that allows you to add in an upper ontology that primarily serves to assist in navigation, to assist in being able to do things like I want to do transitive closures to be able to traverse a document. Those 3 things together essentially give you the latent structure. But then you have the third component or the fourth component to that, which is essentially events. And if you think of most resources out there, most of the things that we are interested in, as being an event of some sort. It has some kind of existence that, it starts, it stops. It has a domain during which it is effective and a domain during which it is not, or is only partially so. That particular model, that particular data set is basically then informed by the taxonomy. It is informed by the schema, but it is essentially the piece that is often hardest to be able to put together in the ontology, because it does require that you get the data in the first place. And we're I come from an XML background. I've worked with data myself. I know a lot of the, as you point out, and I think you're exactly correct. If you have a schema, you can basically translate that schema into RDF almost trivially.
Mhm.
And it may not necessarily be the only. You will have overlaps. And this is a problem that's been in the XML space for a while, of how do you basically deal with information that is essentially non-hierarchical with respect to connections. Where you effectively have two different interpretations. In RDF, that's possible because you can essentially say, look, I have I have these connections across this particular space and these connections across this particular space. And, what you get with that then is essentially that level of being able to go in and talk about information from multiple structural templates simultaneously, which that's been a problem with XML. It's a problem really with JSON, which is, to my way of thinking, is actually metadata poor. Unfortunately, it's become kind of the de facto standard for sending information back and forth. So we're losing metadata left and right.
Has JSON LD been somewhat of a remedy for that?
It's been something that, if you happen to already understand semantics, then you can basically work with it. Problem is, it's really kind of a bastardized form of RDF. It wasn't really intended to be RDF, and when you get right down to it, there's a lot of limitations that you end up seeing with JSON LD because of the assumptions that you're making about structure. It's a lot like GraphQL. GraphQL sounds like a great way to be able to build a semantic database, and as long as your database is relatively simple, it is. But once you get to a point where you start talking about that structural integrity, the upper ontologies, that's where you lose a lot of the value that you get from that GraphQL, because people aren't thinking about that glue layer that really has to be there to be useful. And if you look at something like a DITA, DITA actually has a very, very rich, compelling model. Yeah. That a lot of abstraction, a lot of being able to build interfaces at a pretty deep level. I've studied the schema pretty heavily.
So
JSON,
LD, and I think there's another JSON, semantic JSON makeup, is pretty heavily embedded in websites now, especially with the SEO community being pretty much behind it and Google being pretty much behind it. How can we be the change that we want to see to get them to move off of what we're now saying is a suboptimal means of marking it up for the systems that are out there?
Well, I mean, different use case.
I would agree with Jessica on that. It's
pretty well embedded.
JSON LD is great for SEO because it was designed for SEO. That was its primary purpose. But it's kind of like saying, hey, we've got this great language for building taxonomies called SCOS. And, SCOS is really, really good for what it was in 1995 or thereabouts, when it was first formulated, pre-semantic web. But it has some really significant limitations if that's the only thing that you have to be able to work with in terms of semantics. sorry, go on, Michael.
No, it's great. 100% behind that. I want to sort of just shift the discussion a little bit to scope. We've all been talking this whole conference about developing ontologies and graphs for our content, right? For content delivery, we've mentioned a little bit about data. When I finally was able to justify getting an ontologist on staff, somebody who had 35 years of experience and I really knew their stuff, I needed that person to help me build out the ontology, the domain ontology about taxation, sales tax. It's a big space because there was not a foundational ontology out there I could leap off of. There is in many other areas like legal and medical. And we needed a content ontology, and I needed a tax ontology as well, as we needed it for the content. And I got to thinking, and I said, something? It won't be long until I'm going to need to interlock with CRM, marketing, sales, finance, engineering, the whole 9 yards. So I had my ontologist, Kate. I said, let's go after the whole shebang. Let's go after the whole enterprise. And I know that's gutsy because it's hard enough to do it for just content or just one area. And what we did was we said, well, what's the one thing everybody in the company literally depends on? And we said, well, it's the product matrix, right? Really big product matrix. And went around the company and found out that there were about, 6 or 7, I wouldn't call them ontologies. They were spreadsheets, big, complex spreadsheets. And I said, let's go grab it and let's put it in a formal taxonomy ontology system. And let's make it the source of truth and show everybody that they're all of them are out of date. And we have the only reliable one that actually has an ontological foundation. And we did that. We need to be thinking. And of course, when we did that, now finance came to us and marketing came to us and everybody came to us saying, gee, can we play, in your space? And I need another ontologist, and I already have a handful of taxonomists in all of those areas. But my point I'm trying to make is we can't just think about content as we're developing our taxonomies and our ontologies for content. We need to be thinking bigger. We need to be thinking about what happens when we need to connect marketing's ontology with our product technical content ontologies, and what happens when we have I have an entire ontology, entire set of taxonomies for Salesforce, for support, and so on and so forth. So I know it's a little mind-boggling, but I would encourage all of you out there that talk to your senior management that they need to start thinking not only in the content space, but they need to be thinking beyond it, longer term, so that you don't create islands. And this is where top-level ontology, Kurt, you mentioned them. That's probably a foreign concept to a lot of people, but that's where top-level ontologies come into play, where we can actually weave together we can harmonize our ontologies as best we can, but there comes a point at which you can't, and you have to use top-level ontologies to start tying together the bigger space. And that's an area of it can take us a whole day to discover and talk about.
I would love to touch on unifying elements, because we did touch upon them throughout, where we mentioned schemas, for example. When people are trying to wrap their minds around ontologies versus schemas, I keyed into that because I think it's important to think of what is the transition or what is the transitory state. If you take a database schema, for example, and you take an ontology, can those two work synchronistically?
Yes.
Yes.
Okay. If you're dealing with the role of an upper ontology is basically to provide a set of standards that are relatively context neutral, and that means that there are certain structures that you see over and over again when you're developing databases. You get sets, you get lists, you get, there are descriptions of intervals and how you deal with time. There's units, there's other things like that, which tend to occur from a deep level in terms of the fact that they are things that everyone needs to work with in some fashion or another. They have often different kinds of interpretations, and so they often tend to get left out of the overall process because people look at taxonomy development or ontology development primarily as I want to describe my things. In general, when you talk about those descriptions, you're basically saying, are there deeper level components that make up these things that are common enough that I can talk about? How do you describe a label? How do you describe, labels are surprisingly complex things. It turns out that if you talk about a label in many terms, it's actually easier to say, I have a node that talks about a label value, and I have some additional context that I'm adding into that to be able to say what language it comes from, what version it comes from, what source it comes from, other things like that, for something as simple as a string. And, so understanding what those core deep ontological structures are is actually pretty important. There's some very interesting attempts at being able to build those kind of ontologies. Sometimes they work pretty well. Sometimes, they kind of miss the mark. But, having those in place becomes important because those essentially provide the unifying descriptive layers upon which the topical semantics can then be applied. And that basically gets down to understanding inheritance and where it doesn't work. That gets into understanding when you need to be able to classify, to add classes, and when you basically add just descriptors. There's a lot of best practices that, that's what an upper ontology is. It's basically standards of best practices that make for a good overall structure. And that means that when you go back in and talk to finance, and you talk to accounting, and you talk to marketing, that even though the information that they have may actually be in very different domains, the kinds of information and how they get described, if you have commonality there, it makes it a lot easier to basically build out the ontology that you need.
So that would mean that you would want to then include these stakeholders in the development of the ontology.
Oh, absolutely.
Because their situations, their elements, and their interests might be slightly different.
Right. For sure.
Well, where does the information architect come in? First of all, where does the information architect live? And secondly, when and where do they come in?
I see an ontologist as being an information architect.
Mm-hmm. Yep.
I think there really is no distinction there.
And yet, so many of them don't.
Well, because
many of them do, and I think in the enterprise space, you're probably right. But if you look at the information architecture community writ large, I don't recall ontology as being a dominant skill or tool.
So in my space, I have a chief information architect who is over the technical content, right? Who's working with the help content, the embedded content in the applications, and all of that kind of content. My partner in crime, Michael Priestley with Data, he is the information architect for marketing, and so I think the domains can have their own information architects. Yep. But they also need to understand the ontologies and the taxonomies to the degree that they apply them. And then the ontologists and taxonomists need to work together in a teamed way across functional boundaries to unite. Now, a story I have for you real quick is back at IBM when I was there, Michael, poor Michael, he was given the assignment to take 1,000 taxonomies and try to harmonize them. But taxonomies are they're basically embedded in the applications and the systems. I mean, there's some costs in those things, and I don't think we walked out of a year and a half, 2 years worth of effort with harmonizing any one of them. That's when we learned, oh yeah, we can do that at the ontological layer, and that's why I say layers. You may not be able to get commonality at the taxonomic layer, but you can get into interoperability at the ontological layer, and you can get interoperability of different ontologies at the top ontology layer. Mm-hmm. So I like to look at it in those 3 layers. Maybe there's more. Kurt, you're steeped in this better than I am, but that's the 3 basic layers that I think are obvious to most
and
people.
I will add, because I work as an information architect and have for 25 years, and within my domain space, and it, part of what I do, and the only thing I've never touched UI UX work, which is interesting. I've solely existed on the back end building ontologies, taxonomies, and knowledge graphs. So I think that part of the whole orientation of this conference is the back end, the front end, and the full stack, and really looking at how do we define this space, since there are these different definitions of the same role or the same job or the same thing. Go ahead, Kurt.
Yeah.
Yeah. Oh, sorry, Prasad.
Yeah. I'll just add a couple of things here. I agree with someone that said ontologist is an information architect. After all, we are architecting information. Information is the one that we are dispensing through all these all these automated systems. And so just that you cross the line of a certain threshold in terms of the complexity of the domain, in terms of the concepts and the interrelationships that exist, that a typical taxonomy which is kind of, we see it in the form of a hierarchy and maybe just related here and there, will cross that boundary. And then, you are more trying to make sense of all the relationships that exist in the domain concepts and such. That's where ontology will kind of, allow you to really move it further. And it has all the constructs of really handling, all the variety that exists in the real world that we are trying to model in these systems. And clearly the layers of upper ontology and your domain-specific ontology and the taxonomy is a wonderful way to describe it, that kind of really segregates the complexity that is involved. And if you need more systems to be integrated, there is a lot more fluid movement of information across systems, then you would definitely see a need for an upper ontology being part of your overall plan.
But what we're seeing, and this scares the bejeebies out of me, and I've seen it in my shop, and that is, let's take the case where you've got a CRM and you've got content and you're trying to create a bot to answer both product and account questions, right? I'm still seeing the engineers hardwiring the CRM content into the generative bot. And what I want to see is all of the CRM information become a graph and interact with the content graph and work together. But the knowledge the knowledge that our engineers have these days about knowledge graphs is not that deep. And they're going to fall back to the traditional ways of hardwiring data connections, I fear, at least in the early stages, when really they need to move toward, common ontological, common, enterprise knowledge graph models. And I know that's boiling the earth, and I'm probably breaking a few heads here, but we will be talking about that sooner than later.
Yeah.
If not now.
I would actually go into that, a little bit deeper, because I think it's a very valid point. It's a challenge because the way that most engineers think, first of all, most programmers are basically taught to think imperatively. They're taught to do things. And when you start getting into knowledge graphs, what you're talking about is actually declarative thinking. It's something where you're basically saying, this is true And this is true, and this has a dependency on this. And by making those dependencies explicit, by essentially creating the constraints, this is how the system works. That's a very foreign concept to a lot of programmers. You know, it's a very difficult concept to get in. You're starting to see that as you see more programmers basically work with languages like Haskell and OCaml and other things like that. But even so, you know, Scheme. You know, what's the new ones? And it tells me that I know it's not all that new, but you know, there are a number of these out there that are kind of moving into the imperative declarative midpoint. When we start talking about AI systems, they're actually pretty focused, or should be pretty focused, on declarative thinking and on declarative architectures, because for the most part, those are patterns. Those are patterns that you can basically utilize, and that's really, you know, if you can effectively atomize a lot of the notion of declarative thinking and make that into how you're basically building your software, that gives you the ability to essentially generate a lot of the software that right now is still largely being taken by, I have a lot of examples, and that's basically the way I work. You know, that's what an LLM is doing right now. But it's not actually thinking about it in terms of the fact that, look, you have to have those building blocks, and that is a declarative way of thinking. And that in turn basically means that you have to put more and more of your operational logic into the model rather than into the application. You know, that's a profound shift that I think is we're still undergoing. Marianne.
Yep.
One thing we need to be mindful of, though, is that ontologies have influence outside of, you know, the structure and storage and data and description and connections that we've been talking about. And while we may dismiss SEO as not being very significant, in point of fact, it can have a great deal of influence on how the enterprise succeeds. I tell you that because within my organization, they've developed a technique called intent modeling that is being used to set up navigation structures and relationship structures for the externally facing sites that the enterprise is interested in, because that's how they sell their products. And so what I see is, and my semantic heart is leaping with joy that we have these tools, and that is what it's supposed to be about. But what we need to do is get those other factions under the same tent, so that you're only marking up the content once, or the web page or whatever. I'm going back on mute now.
To jump in, and I'm aware of time here, so I don't want to take up too much time. I'm not arguing that SEO is not important. You know, I managed a major tech site for the better part of 3 years, and you know, SEO was basically what I did day in and day out. I don't think that that's
then
at
you
all.
know how crazy they are.
I know how crazy it can be.
Right. Oh, geez.
I also think that, you know, and I've said this before, schema.org is actually a very useful resource if you are looking at being able to say, I'm wanting to get a high level way of organizing information that allows me to at least get it structured enough so that I can do something else with it. And that's one of the benefits I see out of schema.org in comparison. It's, as an ontology, it's got some problems.
Right.
But as far as being able to say it as a reference, it's a lot like saying, you know, if I want to basically do classification, named entity recognition, I basically say I'm going to point to Wikipedia and use Wikipedia as my reference source for being able to do this kind of NER. And, you know, yes, it has problems, but it is common. It is something that everyone knows, everyone utilizes. It's a great tool for being able to add in that kind of NER type of work that's necessary in order to deal with unstructured content. As far as being able to say, look, I want to get something that's structured and that has a good basic commonality that I can use as a pigeon for other kinds of ontologies. Schema.org is very much there. Now, schema.org has very little in the way of taxonomy.
Would that the SEO community saw that as an ontology, that would be an asset. Basically, what they see it is as a passport to get to position number 1 on Google. And so that's what I mean about, creating a bigger tent, bringing these people in, and having everybody get on the same page for why they're doing what they're doing. So that'll be successful across all the channels.
Right. And the challenge we're facing, and let's bring this back to the business value proposition, right? And I mean, most of us in leadership positions have to present to VPs and executive VPs, is they've delegated data management down to individual teams, individual development teams, individual projects. And, aside from a little bit of master data management, the uphill climb here is explaining the value proposition of why we should build these knowledge stacks, if you will, and weave them together, right? And so we've got to articulate what the business and the customer is going to gain, right? Because I love talking tech all day long, right? But at the end of the day, if I can't say that I'm going to save $1.2 million on this $400,000 investment, or I'm going to reduce the customer CPO score, customer pissed off score, by 10%, or I'm going to eliminate the need to hire, 10 more support folks because I'm going to achieve far higher ticket deflection at the moment that people start, opening a ticket, because I'm giving them exactly the right information so that they can self-service their own problem, or I'm onboarding them faster because, inside of the product, I'm actually giving them real-time assistance that's proactive, not reactive, assistive, not failure mode. If I can turn that into business value and numbers, and extend that with other functions, then we can start to explain and show the business and show the executives why this long tradition of delegating all of this knowledge management and data management down to fragmented teams is the wrong direction, and the right direction is common semantics and common knowledge bases that ultimately lead to enterprise knowledge management.
I agree. That's a great point. And that unifying principle, I think, is one of the strongest lessons learned, is how we can weave this and align on semantics and creating a unified strategy and approach to managing information and data for the benefit of humans and machines. You guys, thank you so much for joining. This was a great discussion. You guys all contributed amazingly well to this really complex domain space that we're just trying to define. So I think first and above all else, defining that information architecture space as being broader than UI UX and broader than just backend knowledge graphs, but looking at it holistically has been, I think, a really powerful conversation.
Great.
Joaquin?
No, I'm thoroughly blown away. All my neurons are firing in all cylinders. I'm largely a non-technical person, more of an operator that likes to figure out what needs to get done, why it needs to get done, and how it needs to get done. And I think it's a beautiful thing to be able to say this profession that has existed in multiple fragmented views, SEO, UX, UI, research, design, backend, it means so many things to so many different people. But in reality, we're looking to consolidate a social technical system. We're all looking to get the same shared representation of reality. And we want to make everything fair, right? That's the whole point of this conversation. Everything needs to be fair, whether it's internally with the knowledge graph, being able to manage and arrest terms and relationships within an organization, or externally if we have to negotiate with SEO or the interwebs, right? How do we represent information using schema.org or whatever common uniform terminology? So I'm thoroughly blown away, and I'm very satisfied with the production and everything that's gone on. I can't wait to see what comes out of this, and we're gonna have to do this again next year. So
Sounds good.
Yay.
Thank you.
Hopefully we'll have more to talk about.
thank you, everybody, and we're gonna make everything available for rewatch in the next 30 minutes or so. So if you want to go back and rewatch the sessions, we'll be right back.
Excellent.
Yep.
Thank you.
So much. Nice meeting you all here.